Matt, Rosa, and Kathy are cousins. If you combine their ages, they would be 40 years old. Matt is 1/3 of Rosa's age. Kathy is 5 years older than Rosa. How old are they? Show several ways to solve the problem. Be able to explain how you came to your answers. Okay. So the first thing we can see is that we can take Rosa's age, and we're going to take Matt's age, and then we'll take old Kathy and her age, and when we add all of these ages together, we should get 40 years. Well, we don't know how old each of them is yet, but we know how old they are in relation to Rosa. Well, Rosa, we can just say is R. Matt, it says up in here, is 1/3 of Rosa's age. So we'll just take 1/3 and multiply it by Rosa's age. Kathy, on the other hand, is Rosa's age. But in addition to that, 5 more years. So we're just going to add all this garbage together and hope that we get 40. Well, maybe easier to see this as 1R and 1R right here. So when I combine all of these R's, we get 1R plus 1/3 R plus another R. And yes, we can make these 3/3 each so that we can combine the fractions. 3/3 plus another third plus 3 more thirds would be 7 of the thirds of Rosa's age. Then we got the plus 5 equals 40. Well, this looks like, or hopefully it looks like it's something a lot easier to solve. So, now we'll subtract 5 from both sides. And we're left with 7/3 of Rosa's age. Would be the same as 35 years. And there's a couple ways we can do this now. Some people would say we would divide both sides by 7/3, and that's okay. Others of you may prefer just to multiply both sides by 3 first, so that these 3's cancel out. So we have 7 Rosas. Now equals 105. And now, when we divide both sides by 7 to get one of Rosa's age, then we find that we get 15. So Rosa is 15 years old. Well, if Rosa's 15 years and Matt's 1/3 of that, then we'll take 1/3 of that 15, which I can just punch into a calculator, which is 5 years. Very good. Kathy, on the other hand, is Rosa's age, and that's 15. But in addition to that, we're going to have to add 5 more to that. So looks like Kathy is 20 years. Make sure you don't forget to label on these problems. Now we should check this thing. So we know that the relationships are all good, but we need to add them all together, and we should get 40 years. So Rosa's age, 15 years, plus these 5 years, plus those 20 years, bam, 40 years. Just like we thought it would be, just like it says right here. And we now know that our answers are correct. All right, number 2. Well, we'll just do every other one, except for some of them we'll do more than every other one. The senior class has 412 students. They're assigned to different homerooms. There are 28 students in the smallest homeroom, and the remaining 12 homerooms have the same number of students. How many students are in each of the remaining 12 homerooms? So to kick this one off, first thing we must do is to make a model. I like models. There's a bar, and then there's another bar. These are equal bars, kind of like in gymnastics. And then one bar is worth 412 students. And then the other bar has 28 students right here. And that would be the 28 students in the smallest homeroom. And then we'll split this thing up into 12 other rooms. 12 homerooms. So how does this compare to the 412 students? Well, we're going to take off 28 of those students because they already are in the room that's smaller, right? Bigger maybe. And then we'll split up, well, that's 412 by the way, and then minus 28 students would leave us with a 4 and a 0 was a 30, 384 students to divide amongst all 12 of the other homeroom classrooms. So we'll just take that 384 and split it up into 12. And we find that there would be 336. Yeah, 36. That's 32. 32 students in each of these rooms. So there'd be 32 in all of these. And we should check these by adding 32 or just taking 12 times the 32. 12 groups of 32, but then we'll add the 28 students right here. When we do these, we should get 412 students. So, yep, it equals 412. Did it in the calculator. Bam. There it is. Well, the answer is not 32. The answer is 32 students.
In each class, homeroom?
Yeah, we'll just say per room.
But we could be talking about.
Sure, but homerooms have kitchens in them, so we're good. Now, some people really like the equations on these. So we know if we take the 28 students and add them to 12 rooms with the same amount of students in each room, it should give us 412 students. And then you would solve this equation, but in any case, you'll end up with 32 students per room. All right, let's do a model on this one because everyone loves models. Yeah, no, this one's not too bad though. So I'm going to use bar models. So the first bar is 25 years because the sum of their ages is 25 years. And then the other bar, we'll split this up into parts. And we see that Billy is 3 years older than Ann. So if we take these two and split them, this is Ann. And maybe this one can represent Billy. But we know Billy is the same as Ann. But in addition to that, he's got another 3 years on that thing. So we can chop 3 years off of this one, which leaves us with 22 other years right here. And now when we split these 22 up into two 11s, we can see that Ann is 11 here, represented by 11 right here, which means Ann is 11 years old. And then Billy, he is 3 years older than Ann, so he would be 14 years. And the last thing we should do on these is to check by adding the ages to get 25 years, which is said, that's what it said up here. If we add their ages together, the sum of their ages is 25. That one was great, right?
Yeah.
We enjoyed that one.
Yeah.
See, we should have been using models the whole time.
Yeah.
So the equation, if you wanted it, not everyone wants it because they love models so much, would be Ann's age plus Billy's, which was Ann plus 3, would equal 25. And you solve this, again, you'll find that Ann is 11 years old. All right, at the store you find a pair of jeans and t-shirt. Together they cost $80.20. The jeans cost 3 times the cost of the t-shirt. How much does each cost? Well, we know we're going to purchase some jeans. That's better. And we'll also purchase a t-shirt. And when we add these, they should be $80.20. Right here. Well, from right here, it told us that the jeans cost 3 times the amount of a t-shirt. So jeans is like taking 3 t-shirts in cost. The t-shirt is like taking a t-shirt in cost. And when we added these, once again, $80.20. Well, some people prefer to see this as 1T. So that when we combine at these, 3 T's and then another 1 T would be 4 T's. And this equals $80.20. So, finally, to solve for T, we would divide both sides by 4 so that we could see how much one t-shirt is. And that appears to be $20.05. Yes, I did. All right. Well, that's not the end of the problem because it asks how much each item costs. So, we got to figure out how much the jeans be, and there's a couple ways we can do that. We can take $80.20 and subtract the cost of the t-shirt, which was $20.05. And that would give us a 15 right here, $60.15. Or we could have said, well, we know that jeans are 3 of the t-shirts. So 3 times 20.05, and bam, we get $60.15 for the jeans. So it's the same for both. If you use one method, then you should use the other method. Check. Otherwise, if you find different answers, you would know that your original answer is wrong. And if you keep it that way, it'll be marked wrong. So a lot of people's, yeah, it's good, right? A lot of people's have been saying that it's easier not to use models or equations, and that's okay if you can. But this one makes it a little bit more difficult because the larger number is 1 more than 5 times the smaller number. What are the two numbers? So, on these, I will make an equation. Let's identify first. We got a small number because we just got 2 numbers, right? And we got a big number or a large number. And when I add at these, I get 41. There we go, right? But it tells us that the large number, the big one, it's 1 more than 5 times the smaller number. So we'll use x to be the smaller number. And then this small number would be represented by an x as well. So I'll add these together and I should get 41. Okay, does everyone see that? The purple here represents the big number, 5 times the small number, but 1 more. Now some people like to see a 1 in front of that x, so that it may be easier to combine like terms. 1 x's plus 5 x's would give us 6 x's. Then we got the plus the 1 equals a 41. Now, we'll just subtract 1 from both sides. And we get 40 equals the 6x. Because this was a 0 right here. Well, what do we do to solve with these? Correct. We divide both sides by 6. That gives us a 1 right here. 1x equals 46. We'll just keep that as a fraction, but we'll simplify these by dividing both of this by 2, leaving us with 20/3. And that'll do it. We do need the other number, right? So x was the small number, which we showed right here. But we need the big one. And the big number, this one is 5x plus a 1. And we found that x right here was 20/3. So, in solving at these, make that 5 over 1. So 5 times 20 is 100. 1 times 3 is 3. We're going to add 1 to these. But we need common denominators to add it. So instead of 1, I'm going to make that a 3 over 3. Which means the big number would be 103 of these thirds. Is the big. It's the big one. So there's the second part. Now we should check. We got the small number, which is 20/3. And if I add the big one, which is 103/3, then I should get 123/3, right? And if I put that into a calculator, I should get 41, which I does, because the sum of the two numbers was 41. The sum of three consecutive integers is 21. What are the numbers? That's a great question, Mr. Sal, but I don't know what consecutive means. Consecutive means that the numbers are all in a row. Numbers such as 1, 2, and 3. Or 4, 5, and 6. 3 consecutive integers. Sometimes they're bigger, like 7, 8, and 9. You just never know, okay? So there need to be 3 in a row. That would give us, added up, 21. Good luck.
So you just think about which numbers, and I at first thought of 5, 6, 7, but that didn't work. It came out to be like 19, I think. So I just bumped it up one, so it's 6, 7, and 8, and if you do, that's about 8. If you do 8 plus 7, that's 15, and 15 plus 6 equals 21. Done.
Nice. Thank you. That problem we dedicate to the French. For a field trip, 331 students went to the museum. Most of the students rode on the 6 buses provided by the school, but 7 students traveled in some cars. If the same number of students rode each bus, how many students were in each bus? Well, this is where a nice model comes in up in here. We're going to use a model up in here, and we can use a bar model if we want. Bar models are very nice. But you could use like a picture model as well. A pictogram, whatever. Well, this first bar will represent the 331 total students. The next bar will represent all of everything right here. So we know that there were 7 people that rode the car. And then we got to divide this up into 6 buses. So 1, 2, 3, 4, 5, 6. So those are 6 buses. So we got to take 7 off of this 331. And that will help us to figure out how many peoples rode just in the buses. So if that were the case, 331 minus the 7
divided by 6.
Gives us 224 students.
300.
Yeah, sorry, 300. That was close.
Divided by 6.
324 students that rode in each bus. All the buses, not each bus. Well, to figure out how many rode in each bus, right here, we would divide this 324 into 6 parts. And we would find that each bus contained exactly
54 kids.
54 students.
54 students.
Well,
How do you
54.
know that?
So each of these is 54. How do we know it's 54? How did you get 54 on that?
I divided 324
Very good. 324 divided by 6.
Why divided by? Oh yeah, because they're comprised.
Yeah, we're dividing them all into the 6 buses.
That was the easiest problem.
So this one has 54 students.
Each bus?
Yeah, we should write this out.
That's a big.
Students in each bus.
Did we get marked wrong?
Oh, you're not asleep.
Students in each bus?
Yes.
Well, it is a word problem, so we should label it. That's a good question. So we did not use
I know.
an equation, right? So what would we do to check it?
54 times.
Go ahead.
You go 54 plus 54 plus 54 plus 54 plus 54 plus 54 plus 7.
And what should it equal?
320.
331. Very good. And it does. If we went through all of these and we added them all together, sure enough, we would get 331. So it does check off, and that's nice. Yvonne was broke as usual, apparently. I don't know what the deal was with that, but then he got his weekly allowance, but because he has a hard time saving monies, he spent half his weekly allowance playing some mini golf. That's worth it. I mean, half your allowance goes to mini golf, bam. I mean, it's either that or do something useful with it, right? So he then earned $4 cleaning out his parents' car. If he now has $12, how much is his weekly allowance? Okay, so there's a couple ways we can look at this. There you go. Good luck.
Okay, so Ivan was broke, and he spent half his money playing mini golf. So then he earned $4. Now he has 12. So he has $12, and that equals 4. But he's adding that, and so this is his allowance. X is his allowance, and we're dividing that by 1/2. So now we have to subtract 4 from both sides. So that's 8 equals X divided by 1/2. And then we have to multiply both sides by 1/2. Yeah, and so this would be crossed out. So now we have to do this one. So X equals 4.
All right. Thank you.
Is she wrong?
Yes, but only slightly. It's not that we would divide it by 1/2, it was just that it would be divided by 2 right here. So what that means is that would divide by 2 right there, would multiply by 2, would multiply by 2 on both sides, right? And then that would become 16. But 16 is not the answer. $16.
Ava, what'd you ask?
The cooking club made some pies to sell to raise monies for new math books. Thank you, cooking club. The cafeteria contributed 4 pies to those made by the club. All of the pies were then cut into 5 pieces each and sold by the piece. There were a total of 60 pieces to sell. How many pies did the club make? Alright, so you guys are starting out. I'm hearing a lot of this 60 divided by 5 stuff. Why would we do that? What information does that give us? Yeah. No.
Oh, that's me.
Why would we divide by 5?
Because that every pie was cut into 5 pieces.
Yeah, every pie is cut into 5 pieces.
And there were 60 pieces in all.
60 pieces and all. So this information would give us, it's 12, but 12 what?
12 pies.
12 pies, very good. So we know from the 60 pieces that it would give us 12 pies, but there's something else, right? Yeah, we got to minus the 4 that the cafeteria gave us, those jerks. So we got to minus 4 pies from the cafeteria. And that leaves us with 8 pies.
I got that.
And that right there would be our answer, but we should check. So hold on one second. Alright, so let's check this. 8 pies would give us 40 pieces. And then the 4 pies from the cafeteria would have been 20 piece.
I think it's cafeteria.
What?
Cafeteria.
Why are you saying it like that?
That's so weird, Ella.
Yeah.
Cafeteria.
Yeah, cafeteria. Alright.
You can't even.
Well, 20 plus 40 would have given us 60 piece, which is how many pieces they told us was there to sell in the first place. So that is good. Alright, the equation would be something like these. Alright, so it was 5 pieces for every pie. Well, we had the number of pies from the club, which is X. And then in addition to that, we had the 4 pies from the cafeteria. And this gave us 60 pieces. So the equation should have looked something like these.
No, actually, Christian says
That would
it's
be it.
cafeteria.
Alright, this is a good question actually, because we divided by 5 first. So see, if we divided both sides by 5 right here, it cancels these 5s out and we're left with X plus 4 equals 12. Then we subtract the 4 pies out. Now if we distributed and solved it, it wouldn't make any difference. But that equation still works. Number 4, Jan bought 2 shirts, Same style and cost, but different colors. Not that that's actually going to matter. And 2 pair of pants. Same style, but cost, but different colors again. Again, that's not important. We just know that each shirt was $3 less than a pair of pants. She spent $49.80 before tax. We're not worried about taxes because we haven't really learned that yet. What is the price of a shirt? And then what is the price of a pair of pants? Well, a couple things up in here. We know that she's going to purchase 2 shirts. 2 shirts. And then she will purchase also 2 pants. And when we add these two together, we should get the total, which was $49.80. So the question is, how much was a shirt? Well, we see up in here, each shirt was $3 less than a pair of pants. So we're going to take a pant and take off $3. Now we're going to add 2 pants. 2 pants like these. That's a P. Let me take that back. That's better. And this equals $49.80. Now we have an equation that we must solve now. Okay, well, let's solve this. We're going to need to distribute right here. So 2 pants minus $6, and then we still have the plus these 2 pants should equal $49.80. And we can combine like terms now. 2 pants and 2 pants would be 4 pants minus $6. And this should equal $49.80. Now to solve these, just use principles of equality, so we'll add 6 to both sides. And now I got 4 P's, 4 pants, equals $55.80. So to solve, I'll divide both sides by 4. And I find a pair of pants would equals, that is correct, $13.95 for a pair of pants. So we should write that in up in here. Let's give ourselves a little space. Pant costs $13.95. So that's for pants. What we need now is the cost of a shirt. All right. Well, the pants is $13.95, and the shirt is just the $3 less than a D's. So that'd be $10.95 for a shirt. So we'll just write that in up here. Shirt is $10.95. Bam. There we go. Here we go. Let's do this one. Tom is training for this marathon. During the first week, he ran a certain distance. So first week,
Thomas is my brother.
we're going to say that he's going to run X miles, right?
Yeah.
And then the second week, it says he's going to run 1.5 times further. So 1.5 times that first week's miles, right? And then the third and the fourth weeks, oh, I didn't do that right, but whatever. He's going to run the same amount of distance, which is 3 miles more than twice what he ran the first week. So we got the first week, twice that, but then 3 miles more. Not just for the third week, but for the fourth week as well. Well, as it turns out, when we add all of these, we should get the total distance he ran, which is 136 miles. Alright, let's go ahead and give ourselves some phantom ones on that 1x right here, so that when we combine our like terms now, so we got 1x, 1.5x, and these 2x's, so that should give us 6.5 of these x's. Then we got this, this 3 right here, and this 3, which makes that plus a 6. Well, all of this should equal the 136 miles. Well, this should be a lot easier to solve now.
Can't run on a.
Alright. Well, to solve with these, I'm going to subtract 6 from both sides.
If you want to do.
Now I still got 6.5x, but now it equals 130.
21.
Now, to solve with these, I would divide both sides by 6.5. So I can get my 1x equals 130 divided by 6.5, 20.
27, 20.
Now, this isn't the final answer. This is just 20 miles for week 1. We need to figure out how far he's going to run on week 2.
I'm feeling alive today.
And that would be 1.5 times the 20, which would be 30 miles. Then we got weeks 3 and 4, week 3 and 4 each. Well, that was 2 times week 1, which is 20, plus the 3 miles. So that was going to be 40 plus 3. 43 miles for weeks 3 and 4.
How did he improve if he ran the same run that last week?
Yep. So yeah, we should check. Week 1, 20 miles. Week 2, 30. Week 3, 43. And week 4, another 43. Bam. That should be 8, 5, 133, 136 miles total. So this checks out. Yeah. Number 6. Cassie and Tom wanted hamburgers for lunch. I like hamburgers, like right when they come out the grill, you know what I'm saying? And then you take the cheese and you just dump it on the hamburgers. And then you take that hamburger. No, it's not more delicious when someone else makes it. You have to make it yourself. I like it on the buns, not on the hamburger. That'd be weird. But then I like to sandwich that hamburger with another hamburger, splashed with cheese, right? Now the cheese that I'm talking about has bacon bits in it too. You know what I'm saying? So then we take slices of bacon and we layer them on top of each other, on top of the cheese that was on top of the hamburger, which was on top of the cheese, which was on top of the hamburger. And then we take a thinly sliced tomato, just thinly sliced. We don't want it too thick because then it overpowers the flavor of the meat. And it's one of those nice juicy ones. It's really good. Kind of like Roma tomatoes, you know what I'm saying? And then we take some lettuce on top of these. Some people like to put extra stuff, like guacamole on it, maybe. You just never know. Actually, one thing that I really like on my hamburgers is fry sauce. Because then, instead of dipping the fries in the sauce, you just rub it off the hamburger, and then it tastes like hamburger and fry sauce. See what I'm saying? And if it's got those bacon bits in it, even better.
That's so disgusting.
And then you take a lightly toasted bun, and you sandwich it all together. Put a toothpick through it because it's too thick. And then on the side, right, you've got your potato fries, the fries. And they've been fried to the point where they're nice and crispy on the outside, but like fluffy on the inside, you know what I'm saying? With a light dusting of salt. I'm more of a light dusting salt guy, but you can have heavy for you.
What kind of drink would you have with this?
I like, it depends. Root beer's good. Really what I would like with it is, one of those mountain shakes that they make. With, I don't know, it just depends. Sometimes it's mint chocolate chip, sometimes it's like a chocolate kind of ice cream base. Whatever's good, really. Alright, now that we got that out of the way, Cassie and Tom wanted hamburgers for lunch, the kinds I was just describing. Cassie ordered a hamburger for $4. That's pretty good for that kind of hamburger, you know what I'm saying? And an order of fries. Tom ordered twice Cassie's order, and the total price was $16.65. What is the cost of one order of fry? Okay, that's a good question. Well, we got Cassie's. And then we're gonna add Tom's order, and this should equal $16.65. Tom ordered twice Cassie's, and she got a hamburger for $4 plus the fries. So Tom will get 2 of these $4 fries and $4 hamburgers and the fries. That's better. And again, when we added these, we should get $16.65. So distribution of the 2 gives us an 8 plus 2 fries. And we still have the 4 fries over the count, $4 hamburger and the fries, and we'll add at these equals $16.65. Well, combining like terms now. Fries, I've got 3 of these fry thingies. And then I've got 4 and then 8, which gives us $12 right here. And 3 fries should equal $16.65. So we will subtract 12 from both sides. And that cancels out, that's good. And we got 3 fries, which would equal $4.65. Then we would divide both sides by 3, and we see that a fry equals $1.55. $1.55. 4 fries. Bam.
Yeah, can I ask my question because I remember?
Lupe and Carlos work in an office. Carlos makes 16 grand less than twice Lupe's salary. So that's actually quite a lot. The sum of their 2 salaries is $104,000. How much are the salaries? Okay, so we got 2 peoples here. Good old Lupe and Carlos. When we add their salaries, we know that we get $104,000. Well, right there it says that Carlos, he's going to make $1,600 less, $16,000 less. So we're going to have to subtract that off of twice of Lupe's salary. So Lupe is just Lupe. So when we add this together, we should get $104,000. Well, to solve with these, I got 1 L and then these 2 L's, which gives us 3 L's. Minus the 1,600,000. Bam. We're getting closer. We're getting closer. So right here, I would have to add 16 grand to both sides. And I'm left with my 3 L's. Equals, that would be $120,000. Well, to find Lupe's salary, I would divide both sides by 3. And then I would find that Lupe's salary equals 40 grand.
A year?
Yeah, per year. Not years, just,
They're talking about a week. I was like,
yeah.
Dude, I meant that in like a minute. Bill Gates.
Alright, well if that's how much Lupe makes, how much does Carlos make? Well, we remember that Carlos, his was twice Lupe's, but then take off 16 grand. Or you could take the 104 grand and subtract 40. Either way, let's try it this way. 2 times the 40 grand. Yep, that's 80 grand, then subtract 16 grand. So then minus the 16,000 gives us 64,000. So Lupe is at 40 grand per year, and Carlos is at 64 grand. If I add those together, I get 104,000 to check it off. Nah. The neighborhood candy store sold 336 candy items this week. Twice as many M&Ms were sold as Snickers. So we know we got M&Ms right here. Then we got Snickers as well. And then 3 times as many Crunch bars as Snickers. So the Crunches are 3 of these Snickers stuff. And the Snickers are twice as many M&Ms as Snickers. So M&Ms, had twice as many Snickers. And the Snickers are just Snickers. So when we add all of these together, we should get 336 candies. Well, that's one Snickers right there. So when we combine all of these, we get 6 Snickers. Should equal 336 candies. So to solve this, we'll divide both sides by 6. And the number of Snickers is 56 Snickers. Well, it didn't want to know how many Snickers. It wanted to know how much of all the candies. The M&Ms is twice that many, so 2 times the 56 would be 112 M&Ms. And finally, 3 times as many Crunches. So 3 times these, 168 Crunches. I like Crunch bars to use in my s'mores. But I like regular, chocolate bars as well. Can you dunk s'more sandwiches in, milk? It seems like it would defeat the purpose, though, right? Oreos and milk is good. What I really like is to take plain M&Ms, dump them in peanut butter, and then eat it like ice cream. No, it's so good. So good. All right, Paul and Ringo went to the music store. Paul bought some guitar picks for $6 and a package of guitar string. Ringo bought some new drumsticks for $8. Then Paul remembered he had a coupon for $5 off. The final bill after the coupon was $15. How much was the package of guitar string? Bam. There we go. Okay, so we're combining these stuff. You got the stuff that Paul's going to purchase. And then in addition to these, we're going to add what Ringo's going to purchase. And this is going to total $15. So Paul did 2 things. Well, 3 actually. He's going to buy some guitar picks for $6. So Paul's got a $6 that he's going to spend. And then he's going to purchase a package of string, which we don't know. And then in addition to these, he's got $5 off. So we're going to take $5 off. Ringo, he's just going to purchase some new drumsticks for $8. So when we add all of these, we should get $15 right here. Well, let's combine all of our like terms now. I got a 6, a -5, and a +8, which is 9. Still plus the x equals $15. So when I subtract 9 from both sides, I will have my x. X equals $6. So it looks like the string was $6. Steve Tyrell and Josh spent a total of $20 at a soccer game. It cost $3 for one of them to get into the game. Each boy also bought a program. Josh bought a foam hand to wave in the bleachers. The foam hand was $5. What was the cost of one program? Here we go. So we got Steve, Terrell, and Josh. That's 3 people's purchasing a ticket. And then they each bought a program. But then in addition to these, Josh bought that foam hand for $5. And this came out to $20. And then it also said that $3, it cost $3 for the tickets. So we're going to replace the ticket with the $3 price right here. So we're just going to figure out how much the cost of one program is by solving this equation. We'll distribute first. So that's a 9 plus 3 programs. 3 programs. Plus the $5 that the foam hand thingy was. And then we'll combine like terms. 9 and 5 combined to give us 14. And we still got the 3 programs plus that $14. Equals $20. So to solve this, we'll subtract 14 from both sides. And we see the three programs, all of them together, equaled $6. And then dividing by 3, we can see that one program was $2. $2 per program. That's all I wanted us to solve for. A total of 960 students attend Bosco Middle School. Some students walk to school, some ride the bus, and the rest come by car. The ratio of bus riders to walkers to car riders is 6 to 3 to 1. How many students come to school by each form of transportation? Well, we got bus riders to walkers to cars, and it's, when we add all of these together, we should get 960 students. Well, do we know how many people car? No, we don't. Do we know how many people walk? No, but we know it's a 3 to 1 ratio with cars, so it'd be 3 times the number of cars, peoples. The buses are 6 times the number of cars because it's a 6 to 3 to 1 ratio. So when we add all of these, we should get 960 folks. Well, that's a 1C right here. So when we combine all of these, we get 10. 10 cars would be the same as 960 peoples. Divide both sides by 10, and those cancel. So we can see that 96 peoples ride on the car. Well, that's just cars. Up in here, we can see that 3 times the number of car people walk, and the car peoples is 96. So we'll just replace that with 96 right here. 3 times 96, 288, thank you. So 288 people walk. And then we've got 6 times the number of people that car would be busing. So 6 times the 96. And 6 times 96 would be, oh thank you, 576 people bus to work, school rather. Now just to check this, we'll just add all these together. 96 plus 288. Oh, not that one. Plus 576. This should add to 960. Bam. It does. Carries a 2.
Is work better than school for you?
Mr. Many Cattle drove to Mexican Head, Utah from southern New Mexico in 4 days. On Monday and Wednesday, he traveled the exact same distance. So you know we're dealing with Monday and Wednesday. On Tuesday, which is between, he traveled 2 times as far as he did on Monday. And on Thursday, he traveled 3 times as far as he did on Monday. So there's Thursday right here. And we know that Monday and Wednesday traveled the same distance. We'll just say it's X. Tuesday, though, it says that he traveled twice as far. So that's twice as far as Monday. Thursday, however, he's gonna travel 3 times as far as Monday. There we go. So when we add all of these together, it gave us a total of 602 miles. Okay, well, let's go and solve with these. Those are 1x's, by the way. So when I combine these, all of my x's together, looks like I've got 7 of these x's, equals 602 miles. And x represents how far we traveled on Monday. So dividing everywhere by 7, it appears that x equals 86 miles. 86 miles on Monday. What fraction describes the part of the trip covered on each day? 86 miles on Monday. So this isn't even finished yet. And Wednesday. 2 times that would be Tuesday's. Tuesday is going to be 172 miles. And then Thursday will be 3 times as much. which will be 240, 258 miles. So what fraction of the trip? Well, I'll give myself more space here. Well, Monday and Wednesday is the same, and that would be 86 miles out of the 602-mile trip. So we just need to simplify this fraction. 43 over 301. That should be it. These can be divided by 43. And that would give us 1/7 of the trip took place on Monday and Wednesday. And then we got Tuesday, which is 172 out of the 602 miles. So simplifying at these, another 301. That's twice as far, by the way, so we could just say 2/7 on Tuesday. And then Thursday is 3 times as far, so that'd be 3/7 on Thursday. So 1/7 on Monday and Wednesday. Bam, there it is. All right, Anna had $60 to spend, so she's gonna start with this $60. By the way, I'm not using an equation on this one, though you could. You got $60 to spend. She's gonna spend, so just on the two shirts at $12.99 each. When we take 2 times the $12.99, the 2 shirts are $25.98. So I'm gonna subtract this from my $60. $25.98. That's just from the shirts. But then we got the candy, which had 3 pounds for $2.89, and that came to a total of $8.67. So we would subtract that out of her total as well. So if we tag on a couple zeros and use a calculator, we don't really need them anyways, we get $25.35 left. Bam. Question. So we got money that she has to start, and then this should equal the money from spending, money spent and money left over. So the money she started out with was $60. This should equal, so the money she spent, that was 2 shirts, so 2 times $12.99 for each shirt. And then in addition to these, she also bought 3 pounds of candy at $2.89 each. And then if we add this to how much money she had left over, then we can solve it. All right. Let's check and see how you guys done.
Okay, try to go really fast and don't talk like
All right. We got distribute right account and right account. All right, after distribution, I get a 3x minus a 12, and over here I got 4x plus 28. Everything else is the same. All right, from right account, what we're gonna need to do is combine it like a term. So I got 13x, negative 2x, and 3x. And yes, Ryan did do it differently, and that's good, okay? So combining at these, I got 14x's, and then I got this 5, and then this negative 12, which combined to be negative 7. Now this should equal the other side. I got 12x's, 4x's, and then negative 8x's, which combine into 8x's. Then we've got this negative 11 and this plus 28, which would be a positive 17 right here. And then we have x's on both sides of this equation. That's no good. So I'm going to subtract these 8x's because I don't want them there. I want them over here. So 14x minus 8x would be 6 of these x's. I still got the minus 7, and this equals 17. Now to solve, I would add 7 to both sides. And I got 6x equals 24. And then to solve this, I would divide by 6. And x equals 24/6.
He said he wanted it in fraction.
Yeah, fraction form. That's what I said I wanted.
Yeah.
So we should simplify the fraction to be 12/3, which is the same as 4/1, which is 4.